Right, so carrying on from our linear equations tutorial, the thing that catches people out the most is what's the difference between simplifying an expression and solving an equation? Because most people lose denominators when they're not allowed to lose denominators. Let me show you what I mean. If I'm simplifying an expression, this expression has denominators. There's 2, 3, and 1. So as we've seen before, I find a lowest common denominator. What's the lowest number that 2 can go into, 3 can go into, and 1 can go into? And that is 6. Now what that means is I can rewrite this fraction over 6. And I can rewrite this fraction over 6. And I can rewrite this fraction over 6. I'm not allowed to multiply each of these by 6 in the hope that it'll cancel those denominators, because this is not an equation. So the rule of what you do to one side, as long as you do to the other side, it's fine, does not apply here. In this example, this is an equation. So I may multiply each of those terms by 6, because in an equation, as long as you do the same thing to both sides, that's fine. In an expression, you can rewrite each of these fractions with a denominator of 6. You can't multiply. So if you're simplifying an expression, your denominator doesn't magically disappear. So if I want to rewrite x over 2 as a fraction over 6, I can say to myself, right, I can multiply the bottom by 3 as long as I multiply the top by 3, because then effectively I'm not changing the meaning of my fraction. I can multiply the denominator with the 3 by 2, and I multiply the top by 2, then I'm not changing the meaning of my fraction. And I can multiply the denominator 1 by 6 as long as I multiply the top by 6, and then I'm not changing the meaning of my fraction. But I can't just magically multiply by 6 to get rid of it. I can only do that in an equation, because as long as I do one thing to one side and I do the same thing to the other side, it's fine. Now here, I cannot get rid of that denominator. I can simply simplify the numerator. So I get x plus 24 over 6. I'm simplifying. My denominator doesn't magically disappear. On the other hand, with an equation, I can multiply by 6 with pleasure. I'm not changing the meaning of the equation because I'm doing the same thing to both sides. I am changing the meaning of this fraction, but that's okay because the equation isn't changing meaning. So notice the very important difference. So in this case, 2 goes into 6 3 times, so I get 3x. 3 goes into 6 twice, so I get minus 2x, equals 4 times 6 is 24. So notice I have exactly the same things, 3x, 2x, and 24, but the denominators magically disappeared, only because I've multiplied both sides of an equation by it. So now I can simplify, and I get x is equal to 24. So please don't, when you're simplifying an expression, think you can magically get rid of this denominator. You only multiply by a denominator when you are simplifying and solving an equation. So it's a very important difference. Now, we need to stop and stop this video, write down these 3 examples, and solve these very difficult fraction linear equations. Don't forget that because these are equations, you may factorize, find the lowest common denominator, and you may multiply each term by that lowest common denominator, but only because these are equations, and as long as you do the same thing to both sides, you're not breaking any mathematical rules. So take these down, stop this video, and practice your linear equations. Good luck.